6, which is compound inequalities, following what we just did, which is inequalities in one variable. So relates to what we've been working on, just an extension of that. So we're going to create and solve a system of inequalities. A system is anytime you have more than one thing going on at a time. So we're going to do systems of inequalities today, simple inequalities, and then we're going to do systems of equations later. Eventually we're going to get to where we graph these on, not just on a number line, but we're going to graph them in a two-dimensional plane. And so we're working our way up to more complex things that we'll get to later in the year. We will interpret the solution to a compound inequality within a modeling context. That does not mean like, modeling clothes. That means modeling a set of scenarios within a problem, okay? All right, so here we go. Hannah has some blue paint. She wants to lighten the shades, so she mixes in a cup of white paint. Still too dark. So she dumps in 1 cup of paint at a time. After adding 4 cups, oops, she went too far. Now it's too light. So explain in words how much paint Hannah should have added initially to get the shade she wants. Don't overthink this. This is a simple kind of thing they want us to think about. Kurt.
So would the question be like we could just use like W for white paint, like
Absolutely.
W.
But now we're not even writing it yet. We're going to do that in just a second once we've said it in words. So just explain in words what she should have done. Ben.
She should have added halves of cups of white paint.
Okay, that's a strategy, but I'm just looking for like an explanation of how much paint she should have added. Trip.
Up to like 3 cups.
Okay.
3 to 2.
Give me a more general. I'm not looking for anything that specific. I'm looking for a more general.
2.5.
That's too specific. Holton.
Less than 4.
Okay, that's a great start. That's half of it.
More than 1.
More than 1 and less than 4. She needed more than 1 cup of white paint because 1 cup wasn't enough. Then she got to 4 cups and that was too much. She needed somewhere in between that, right? We don't know how much. We don't know what she was looking for. It doesn't matter how much. But she should have added more than 1 cup and less than 4 cups of white paint. That's really what we're looking at. So represent your answer to part A with 1 or more inequalities. So now, Kurt, what are we doing?
So I think we do like have X for the color she wants, I guess.
I like when you said W for white paint.
W for white
Yeah.
paint. So
That was really good. Okay, so W, and then what did we say it needed to be?
less than 4.
So we need W to be less than 4. Okay,
W also needs to be greater than 1.
but W also needs to be greater than 1. That, fellas, is a compound inequality.
Fellas.
We're using the same variable to describe two different sets of outcomes.
That's easy.
Okay? Didn't that great when it that's easy so far. All right. So Hannah decides that she likes the shades of blue that appear in between adding 1 cup and 4 cups of white paint. How can you represent the number of cups of white paint that yield the shades Hannah prefers? So we can actually write this one in 1 inequality. Bennett.
Does it want us to write a graph?
An inequality, not a graph. We will end up doing some number lines as we move along, so we can do this actually in 1 statement. Rudy.
Okay, this is I don't think this is right, but I'm just venturing a guess. Is it 1 cup at like less than 4 cups?
1 is less than 4, but we're not relating 1 and 4. We're relating 1 and what?
W.
1 and W. So 1 is less than W, and W is less than 4. Okay? So you were on the right track. Okay? That's a compound inequality. It's a simple one, but and we're going to see some that are, start out a little trickier than that, and we have to solve them. But that's what we're doing. We're doing compound inequalities. Okay? Does that make sense?
W.
So far?
Mhm.
All right. Well, let's see if I can jumble it up a little bit. All right, here we go. Okay, how can we use inequalities to describe the set of numbers graphed below? Okay, So we've got a number line, and it represents a scenario, and so we need to write a compound inequality.
I think I got it.
Okay, Bennett, go ahead.
X is less than or equal to -3.
Okay,
Hold on. Okay, and then X, or not, wait. Oh, and X is bigger than negative, or not negative, X is bigger than 2.
okay, all right, and you used an interesting word there. You did really well. Those two statements are correct, but you used an interesting word. You said the word and.
Oh, well, I meant them in one, but.
Okay, which is not your, I'm not trying to correct you for doing something wrong because we haven't talked about this yet. But you said and. Now, is it possible for a number to be less than -3 and bigger than 2?
Yeah.
There's a number that can be both of those, less than -3 and bigger than 2? There's not. So we can't use the word and. And hurts us there because there's no possible way that can happen. So what's a word we could use, Rudy?
And then another variable is bigger than 2.
Or.
No, we still want one variable. We're gonna use one variable. These are, yeah, so that's a good thought, but we want it to, otherwise they wouldn't relate to one another. Kurt? Or. Okay. Or, so there are gonna be two types of inequalities. We're gonna have some ors, and we are gonna have some ands. Okay, and we've got to learn to judge which one is which, when it's appropriate to use one word or the other. Okay, so words matter, right? Okay, so X is less than or equal to -3, or X is greater than 2. It can't be both. All right, so this is a compound inequality. This is what we're doing. We're gonna do kind of both ways, where they give us a graph and we write the inequality for it. We're also gonna solve for some inequalities and then graph them. So we gotta go both directions here. Okay, so. How can you use inequalities to describe the set of numbers graphed below? So let's talk about this graph. What do we have here?
This is one of the inequalities again?
Cooper.
X is less than 1.
X is less than 1. I like it. Rudy.
And greater than -4.
And X is greater than or equal to, the dots filled in, -4. Okay? So, when we write an and inequality, there's a couple of ways we can write that. And there's always more than one way we can write inequalities, right? We talked about that in our last lesson where you can flip them around. We could write this one as 1 is, whoops, I wrote that backwards. 1 is greater than X is the same thing as X is less than 1, right? So we can monkey around with that a little bit. We can turn some things around and have those written differently. But with and inequalities, we can also write those in one statement. And so if we do -4 rather, and then I put my symbol, which is -4 is less than or equal to X. And then I have X is less than 1, okay? And so that's a way to write it. This is still an and inequality, and we can write it that way just in one
See, we don't
statement.
even need Colin. We're smart today.
Hey, we can do it on our own.
Yeah.
All right, Kurt.
It's kind of funny. We're learning about conjunctions and math.
There you go, all right? I was looking at, I try to get a math t-shirt every now and then. I've got some math shirts, and I was looking at one last night that says grammar is important, but math is importanter. So I was thinking about getting that one. I might get that one this year.
So
All right.
What does McPherson wrestling have to do with math?
Well, this is just it's not a math shirt, it's a wrestling
Well, in
shirt.
wrestling, you have to calculate the
You gotta count, the number of seconds or points or whatever. All right, let's do this one. Write a compound inequality. Cooper.
X is greater than -2, and X is less than or equal to 6.
And X is less than or equal to 6. I like it. That's one way of writing it. How else could we write it? Bennett.
-2 is smaller than
Less
X.
than.
Or less than, sorry.
That's okay. I knew what you meant.
And x is
Which is
less than or equal to 6.
There we go. All right. To me, this way, I like the and ones, especially doing this, because it kind of just follows the number line. You put the smallest number that's marked first. You're always going to have either a less than or equal to than your variable. And then you put the biggest number last, and you're always going to have either less than or equal to. Okay, so you just got to get the symbols in there. It always follows kind of this pattern. The ands, to me, are like, my brain likes those. I don't. To me, they look easier that way. But this way is fine too. I will accept these. All right. Now, what if we have more like algebraic expressions written as inequalities? We can still solve those and come up with a way of graphing our solution. So it's a compound inequality. It tells us what it is. It's an or statement. Okay, so we need to graph it. We need to graph our final solution that respects what the symbols tell us. Okay, so we just solve each one independently. We know how to solve this. So how do I solve 5x minus 7 is less than 13? Add 7. So 5x is less than 20. Divide by 5, so x is less than 4. Okay? Now, solve the other one. I'm going to do the other one. I'm going to switch colors so that we can, minus 3. So negative 4x is greater than 8.
And then you have to flip the sign.
Divide by negative 4. And Bennett, what'd you say?
You have to flip the sign.
We divided by a negative, so we've got to flip the sign. That's right, negative 2. Okay? So I'm going to graph my first one. X is less than 4. So I'm going to put what symbol? Open circle. And it shades to the left because it's less, right? Okay, and then I'm going to graph my other one so we can see how they interact with one another. What symbol? Open at negative 2, and it graphs where? X is less than negative 2. Less goes left. This is an interesting one because it starts off as an or, and it kind of morphs into really a single inequality. You know, if I was graphing it all, if I had just graphed it all in red, then it would run together.
It's just all this.
Okay, so really, kind of x is less than 4 becomes kind of the dominant portion of that answer. And that's okay. That's the way they come out sometimes.
How is it an or? Can't it be an and?
It can't be an and because you don't have any numbers that are both small. There are some numbers that are not smaller than 4 and smaller than negative 2. Like if the answer is 1, it's smaller than 4, but it's not smaller than negative 2. So we can't change it to an and.
So if it has options that are not answers to both, it cannot be an and.
It cannot be an and, yeah. Okay, and so there are numbers that do both, but there are some numbers that only satisfy one of these, and then of course there are numbers that don't satisfy any of them. So we still have to keep it as an or. We would write our solution, in fact, we would write it, you know, this would be the way we would write the solution. Does that make sense? Okay. So we have to include all of the solution. We have to graph it in a way that represents the solution. Now, normally if we had this, like if we cut this part off and if the only inequality we had was x is less than negative 2, would negative 2 work as a solution? No, because negative 2 is not less than negative 2, right? But if I also include or x is less than 4, now does negative 2 become part of my solution?
Yes.
Yeah, so as I shade in from negative 4, or shade in from to the left of 4, it kind of shades in that box, and that's okay. All right, so that one, you know, that one might be a little bit, that one gets more confusing because the or can be confusing, but we've got to keep it the way it is. Okay, so we may have to do some work before we solve, so let's do this one. Start here, subtract 2, negative 3x is greater than negative 9. Divide negative 3. Whoops. That's a funny looking 3.
X
X is less than negative 3.
X is less than positive 3. Okay? And it starts out with an or, so we got to keep that in mind. So now, we could just, I'll tell you what we could do, rather than distributing, we can just divide by 2 to start, right? So x minus 2 is greater than or equal to 3. Add 3, so x is greater than or equal to, add 2. Thank you. Thank you for catching me before I got too far. So add 2, x is greater than or equal to 5. So,
Oh, I just distributed it, but I got the same answer.
well, yeah, and that makes sense, and that's okay. I just took different steps. You should get the same answer.
Yeah, it makes more
Okay,
sense to
so,
distribute it.
well, that's fine. If you want it, distributing it is fine. I don't have any problem with that at all. But we should get to the same answer. So, x is greater than or equal to 5, so solid circle there in that direction. And then my other one here, x is less than 3. And it shades this direction. So this one comes out the way we would expect an or to come out. So we still need to make sure that we write our answer as a single expression. So x is less than 3 or x is greater than or equal to 5. Okay? All right, what about the old and statements? So these, a lot of times, will just be written as one expression like this. We've got one expression that's got 2 different symbols, and so we need to split those in 2 in our own minds. So I'm going to start here. I'm going to cut it there, and I'm going to cut it there. So we're going to do our first one would be negative 12 is less than or equal to 7x plus 9. But we also have 7x plus 9 is less than 16. We've got to solve both of those. Okay? So, subtract 9. Negative 21 is less than or equal to 7x. Divide 7, so negative 3 is less than or equal to x. And then we have this one. Subtract 9, so 7x is less than 7. So x is less than 1. So negative 3 is our smallest number, shaded in. And x is less than 1. 1 gets an open circle. And so x is greater than this one, which means it shades to the right. X is less than this one, which means it shades to the left, so it's that middle section that shades. And that's what an and should end up looking like. Okay? So then we would make sure you write your solution as one statement. Negative 3 is less than or equal to x is less than 1. That's an ugly less than symbol. There we go. All right, let's do this one. So now this time they give us kind of 2 different statements, but they join those statements by and, so we kind of know what our solution set should look like if it's an and, right? It's got to meet both conditions. And so negative 2x plus 1 is less than 4. Negative 2x minus 2 is less than 4. Add 2, so negative 2x is less than 6. Divide negative 2, so x is greater than negative 3. And then subtract 1, 4x less than or equal to negative 4. So 4x is less than or equal to negative 1.
I'm good like that.
Okay? So if you're drawing a number line, just get enough information on the number line that you can make your graph work. So my smallest number is negative 3, and x has to be greater than that. Then I've got a negative 1, and x has to be smaller than that. Right? So x is smaller than negative 1 and bigger than negative 3. So negative 3 is less than x is less than or equal to negative 1. Everybody good so far? All right. Let's talk about, dog food. Enrique plans a diet for his dog, River.
These names.
I know, right? River consumes between 510 and 540 calories a day. If River eats 1.5 servings of dog food each day, how many treats can she have? So she needs 510 calories is the lowest number she needs. You know what, I'm gonna not have room if I start there. I'm gonna start over, and I'm gonna move some stuff up out of the way, which is out of there where I can't see it. How about if I do this? I'm gonna shrink it. Okay, there we go. Now I'll have more room. Okay. All right, so actually the answer is not 4. If you'll think about it for a minute, you'll understand why I said that. So 510 is the lowest number of calories, and then that's the smallest number. So it'd be less than or equal to 1.5 times 320, because he gets 1.5 servings of this, right? Plus 15 calories per treat, which we don't know, and then it's less than or equal to 540. Okay, so I've got 2 inequalities to solve. I think you guys will follow if I do it all kind of at once. What's 1.5 times 320? I know what it is. It's 480.
Why do you know that?
Because I looked at it in the book earlier. 15x is less than or equal to 540. Now, I can work both sides at once. Okay, I can subtract 480 from here, which means I need to subtract 480 from here, but I also need to subtract it from here. Does that make sense? I'm not losing, I don't want to confuse you guys, but I'm just doing all the steps at once. So that would be 30 is less than or equal to 15x is less than or equal to 60. Okay?
It's 2 to 4 treats.
Divide by 15 on both sides of the symbols. So 2 is less than or equal to x is less than or equal to 4. So 4 is not the answer. The answer is 2, 4, between 2 and 4. Holton. Sure. All right. The answer is 2 to 4 snacks. You should.
I feel like it's easy to solve. The only hard part of this kind of thing is to get the equation.
Setting it up so that it reflects what it needs to be an and, not an or. It needs to, you've got to get the things in the right place. So, and that's all right. We just, if it's hard to figure out, it's just because we haven't practiced enough. All right. So, I'll offer you this. That is the last slide of the actual lesson in the book. I've got more slides I know that are on your page. Those are just additional examples. Do you want to work some additional examples together, or do you want to go to the homework?
Homework.
That's what I thought you'd say. All right, so the homework is online. It is, it's on Savas Easy Bridge, so it's there already.